Bonjour tout le monde, ici c'est Aladdin Physics avec un nouveau physics vidéo. Et sa vidéo là c'est pour un étudiant du grade 9. Et nous vous guettons écoute comment nous allons solve un problème dans electricity et motion. Donc la première question c'est une question sur electricity. Donc il y a two resistors, 60 ohm and 20 ohm. Are connected in series in circuit A and in parallel in circuit B as shown in the diagram. The electromotive force of the power supply is 240 ohm. Explain what is meant by the power supply having an EMF of 240 volt. So this is part A. So we are going to say that an EMF of 240 volt means that the power supply does 240 joule of work per unit charge in order to supply electrical energy to the circuit. Now let's look at part B. First part, we have to draw in circuit A the symbol of a voltmeter connected to measure the potential difference across the 60 ohm resistor. So we have our circuit here. A voltmeter is always connected in parallel. So we connect it like this and we get the answer for B, first part. Now let's look at B, second part, where we have to find the potential difference across the 60 ohm resistor. So here, this is a potential difference that we are asked to find, which is the reading of the voltmeter. So here what we are going to do is to find the current flowing in the circuit. So the current flowing in the 60 ohm is the same as the current flowing in the 20 ohm. So we combine the two resistances into 80 ohm so that we have only one single resistor for 240 volts. Donc ici, là, à ce là, on est capable de servir l'équation R égale V over I qui permet de gagner courant. Et là, qui m'a fait, je resservi R is equal to V over I pour me calculer potential difference across the 60 ohm. Toujours me faire ressortir qui 240 volts, il n'est pas pour 60 ohms là, et il n'est pas pour 20 ohms là. Ce qui était, c'est le total potential difference across the whole circuit. Alors, ce qu'on va retrouver ici là, 60 ohms là, il prend 180 volts. Tandis que 20 ohms là, il prend 140, ça veut dire 240 retirer 180. Alors, ce qui fait toi 60. Ok, là, 60 plus 180, là, il réfère où? 240. Donc, ça, c'est très important. Alors, nous avons partie C, première partie. Quand il dit nous comme ça, draw an ammeter to measure the current flowing in the 60 ohm resistor. Here we are talking about circuit B. So in circuit B, to measure the current in the 60 ohm resistor, we have to place the ammeter in series with the 60 ohm resistor, so that the same current passes through the ammeter and through the 60 ohm resistor. Now the second part, we have to find the effective resistance of the 20 ohm and the 60 ohm. So we apply what we know, which is we combine them in terms of reciprocals so that we get R equal to 15 ohm. Now remember, do not add 20 plus 60 in this case because the two resistors are in parallel. Now part 3 of part C, the third part, we are asked to find the current delivered by the battery. So here again, we can reduce the circuit into one single resistor of 15 ohm with 240 volt applied across it, and we use R is equal to V over I to get the current, which is going to be 16 ampere. Now we have question 2, which is a question on motion. So we have a driver in a car and a motorcyclist on a motorcycle race against each other on a straight horizontal level road of 1000 meters. The speed time graph shows the variation of the speed with time for both the car and the motorcycle. So the first part A, première partie. Alors, ce qui nous comme ça, define acceleration. Donc, pas oublier qui acceleration nous définit en termes, alors c'est-à-dire the change in velocity per unit time. La deuxième partie, c'est we have to find the acceleration of the car. So we can use the equation A equal to V minus U divided by T. Then we can use the graph to get the values of VUT. So we get the values T at T equal to 50 seconds. Donc U li 0 parce qu'il y a T égale 0 li. So vitesse 0, le graphe là commence au 0. Et vitesse à T égale 50 secondes, vitesse là li 10 mètres par seconde, c'est ce qui me remplace comme capital V. À ces enfants, il n'est pas nécessairement obligé de prendre T égale 50. Il est capable de prendre T égale par exemple 100. C'est mal là, ce V type différent, ce V type 20. Donc ça, keep that in mind. Now, part B, we are asked to find the first part is the distance covered at T equal to 55 seconds by the motorcycle. So here we have to find the area under the graph. So here, this area, we can break it into two parts. We have D1, which is the triangle, and then D2, which is the rectangle. And then we can add them to get the total distance covered in the 55 seconds. So here, D1, which is the area of a triangle, half times base times height, we get 375 meters. And then D2, which is the rectangle, length times breadth, 25 multiplied by 25, giving you 625 meters. Et là, the distance covered is, donc nous avons tous les deux, nous gagnons 1000 mètres, ça veut dire qu'il couvert 1000 mètres dans sa 55 secondes. C'est-à-dire, partie B, deuxième partie, nous avons une distance qui est couverte par le tout là, dans 55 secondes. Alors, c'est toujours area under graph. Ici, il est simple, c'est un triangle. Alors, c'est distance égale half times base times height, which gives you 275 meters. C'est la partie C. Disons-nous comme ça, from your answers in B, first part, and B, second part, state who won the race. In fact, here, it is a motorcycle. Parce qu'il se guette bien, motorcycle là, il finit couvert 1000 mètres dans ça 55 secondes là. Par contre, l'autre là, finit couvert 10 275 mètres. Alors, c'est une finit arrive au but, tandis que l'autre là, il couvert 10 275 mètres. Ça veut dire si je guette bien, si je prends 1000, je retire 275, je vous gagne 725 mètres. Ça veut dire qu'il le 2 là, il 725 mètres par derrière. Ok? Alors, je m'espère que vous avez enjoy la vidéo là. Donc, toujours, pas oublier de mettre un like et subscribe on the channel et aussi, pas oublier, share la vidéo. Merci beaucoup. Until next time.